Hey Blake, how are we doing? Who else we got in the chat? Let's get Mewbot awake right here. Hey Taylor, good to see you here. Let's see who all we got. We got Taylor, we got Blake. We're gonna wake up Mewbot. My hair's all wet today. Ah! It's raining here in Texas. Anyways, good to see you here. Let's get Mewbot awake. Waking up Mewbot. There we go. Hey. Getting things ready for a big survey we're sending out. We're doing a big technology survey. Whatever questions you have, feel free to ask. Big technology survey coming out today. So, woo! Been working on that. Good morning, Mew. Let's see, is he awake? Oh, he's awake. He's awake. There we go. Let's give out some points. What questions are there? What questions are there? Drop those questions in the chat. Feel free to ask them. What question? It's time for maybe at the end. Maybe he announces things. That is his job. Or is that, sure. I'm working on the survey in the background. Should we make? Yep. Let me make that right away. Make a change to our survey here. See canvas content. What is the weakest correlation to matrix? So yeah, let's do canvas content. How's that sound to you, Taylor? Let's do some canvas content. Make a real quick change to the survey, and let's see right here. Let's work on the canvas content. Where is it? Where is that question? One quick song right here, and then we find that. There we go. I think that's got it. You're good to go. I have a lot of questions regarding the exam. Ask away, Blake. Good to see you here, John. Thank you, everybody. Getting the survey going here. Okay, let's do the canvas content. Oh, it's gonna have me log. Has anyone noticed where it's having you log back into Canvas every 2 seconds? Okay, it didn't have me log back in, but it's still doing it. It was doing it all yesterday, all this weekend. Maybe it like doesn't do it during the week. Oh, today is the canvas content day. All the weekend. It is awful, I know, right? Driving me crazy. Driving me crazy. Let's check it out right here. Go. Let me make sure this is published. Let me make sure we want to sing over here. Okay, it is published. It should be good to go. Let me go to preview. Checking out my survey, just making sure we're doing some final updates to it. So many final updates. We got this. Is it gonna crash? What is going on? Let's see. 2 seconds here, everybody. Sorry. What is going on with my survey is crashing. Okay, now it's working. Okay, it works. It works. Let's say, whew. Okay. Good. Let's see. Looks to be working now. Canvas content. Let's get canvas content going over here. Keith, good to see you here. How you doing, Keith? Checking out those points there, Keith. Are you... Oh, separate accounts. Okay, let's get Canvas content. We are here at 625. Stat 201. Canvas content number 4. Let's do this. Hop over to the main screen. Here we go. Okay, so this is Canvas content number 4, and let's check out some info on it. Now remember, these are example test questions, so write down the material, write down how to solve them, and let's understand what's going on. What is the weakest correlation in the matrix? So these are just variables like variable A, variable C, variable B, all are just names of the variables. And so how do we find the weakest correlation in a correlation matrix? Well, check it out. Core matrix can be done over here. So if you're in the upper level classes, it's pretty easy to make a correlation matrix. We go here to core.matrix. There it is right here, core matrix. And we can get a correlation matrix. So here is a correlation matrix. The weakest correlation would be the correlation closest to what? Now, this is a pretty crazy big one. The weakest correlation would be the correlation closest to what? Closest to 0. Wow, Keith is already there. So, Keith, you are right. The correlation closest to 0. Now, this is pretty tough to look through right here. We actually have better commands in the upper level classes where we do things like all correlations, empty cars, sorted, and then we say strength, or let's go magnitude. Magnitude. And here is the weakest correlation. The one that is closest to 0 is between AM and carb. So that is the weakest correlation. The strongest correlation is the one closest to what? What is the strongest value of correlation? Closest to what or what? Good job, Blake, right there. Weakest is closest to 0. Strongest is closest to what? So here's the top 3 strongest correlations. Strongest 1 or -1. You see how when I sorted by magnitude, the ones here at the top are 0.9, 0.88, and -0.86. So the sign, as The Rock always tells us, it doesn't matter. The sign doesn't matter when it comes to strength. The sign only indicates what? Like negative or positive only indicates what? And these are all values of correlation right here. Negative or positive only indicates what? The what of the correlation. We have strength, something, there you go, direction. So it only indicates the direction to us. So the direction is only indicated by the sign. So when we look over here at this correlation matrix, the correlation between E and E doesn't matter. And D and D, those are just kind of ones that don't matter because they're the same variable connected to each other. Good to see you here, Evan. So what is the weakest correlation? Enter in the value. What is the weakest? It's the one closest to 0. So what is it? I think I see it. You have to look through the pairings of them and find the one closest. Close. Not quite, Blake. Good guess. Good guess. Oh, you're saying A and E. Evan sees it. It's going to be 0. I believe it's that right there. And so whenever you find an answer, like if you see negative 0.06, then ask, is there something else closest to 0? No worries. No worries. Yeah, it's very easy to miss. And then just make sure, like if you go to this answer right here, you just want to make sure, because this is why, especially in the upper level classes, like if I asked you to find the weakest correlation in here, would you be able to find the one between AM and was it, it's this one right here, AM and carb. It's this one right here is the weakest out of all of these. That'd be so impossible to find right there if you're looking through all this. That's why we use code like this to find the weakest right here by sorting it. So we just sort the whole matrix and remove out the redundant ones. The redundant, or the ones that don't matter, the ones between like miles per gallon and miles per gallon. Is the homework 6 and quiz 6 just designed to frustrate me? No, Evan, we'll take a look at it. Victoria, good to see you here. We'll take a look at it. They're tricky. They're good practice. And this is a correlation matrix. It shows us the pairwise correlations. So make sure to know how to read it and find the weakest ones, which are closest to 0, and the strongest ones that are closest to 1 or -1. But the ones that are A and A. Can we do quiz 6? Yeah, name a question. We'll do it. A p-value for a correlation which is statistically significant implies that the correlation is due to random chance. So the p-values, what does the p of a p-value stand for? What does the p of a p-value stand for? What does the p of a p-value stand for? I'll work on Canvas content. Probability. So a p-value is literally, by definition, the definition of a p-value is the probability of our observed results or results more extreme given by random chance, given the null is true. So the null hypothesis is very important here. We will assume things like, ooh, we'll do that here in a moment, Evan, you got it. So the null hypothesis is with the starting assumption. So when you do it with correlation, the starting hypothesis is there is no correlation. We can write this out. The null hypothesis states that correlation is equal to 0. The alternative hypothesis, which is another belief, is that the correlation is not equal to 0. Does it make sense that someone must either believe there is no correlation or there is correlation? There is no correlation can be defined as correlation 0. There is correlation can be defined as correlation is not 0. R is the value of correlation. And if the null hypothesis is true, how should this look? Good questions right there. Or people, thank you, Taylor, for helping out. Taylor points. If there is no correlation, then how should a scatterplot look? If I draw a scatterplot right here, which meets the null hypothesis, that would be something expected or likely given the null. What is likely to see given the null? If the null hypothesis is true, then what is likely to see? If the null hypothesis is true, if there is no correlation, what's likely to see? Good question, Roshni. If there is no correlation, then what is likely to see? The points would look how? So if there is no correlation, the points would look how? Like if there's no correlation at all, the points are going to look how when I draw them? What do you think? If there is no correlation, then the points are going to probably like an oval or something, right? Because that's no correlation, right? So does this look likely by random chance or unlikely by random chance? Does this result right here, which has a correlation close to 0, look likely by random chance or unlikely by random chance given the null is true? Does it just say likely or this looks likely by random chance? Because remember, the correlation is 0 and we saw something that looks like no correlation. So if there is no correlation, it's likely that we would see that. Does that make sense? It's weird how we statisticians talk, but we're like, let's say this. If Brian can run a 5-minute mile, then is it likely? So if I claim to you I can run a mile in 5 minutes, is it likely to go out and see me run a mile in 5:02? Is that a likely result? Like if you're watching me just run a mile and I'm like, I ran a really fast mile and you see me run in 5:02. If I am a 5-minute mile runner, is it likely to observe me running a mile in 5:02? Yes. Is it likely to observe me running a mile in 15 minutes? At this point, that sounds like if I was like, I ran a really good mile. And you're like, you ran it in 15 minutes. I'm like, yeah, that was pretty good for me. You're like, I don't think you're a 5-minute mile anymore because that's an unlikely result. So now we would say we would reject the null hypothesis and you wouldn't believe that Brian's a 5-minute mile runner. You'd believe he's not a 5-minute mile runner. You'd have evidence for the alternative that I'm not a 5-minute mile runner anymore. So with this right here, the alternative is when we look for there being evidence of something different than the null, and this looks like there's correlation not equal to 0. So the p-value over here would be something high because this is a likely result if there is no correlation. This is likely to see, where this one would be unlikely to see if there is no correlation. So I can do this over here and show this exact result by making correlations that are by random chance. And let's go right here to y is equal to 100 random normal numbers. These are just 100 numbers. And x is equal to also 100 numbers. And then let's look at a plot of y and x. If you look at the plot of y and x, it's just a random scatter of points. So now we can run the correlation between these. And the correlation is very small, and the p-value is very high. So the correlation between this actually is a little bit negative. Does that make sense there, Evan? There is a slightly small negative correlation between these points. And you see how the correlation is small, close to 0, and it looks likely by random chance? Well, if we did something over here where we had x and y being the numbers 1 through 100, and then we had, let's go plus a little bit of random norm on here. And then right over here, same thing for this. Now when we plot it, we get something like this. Now the correlation is going to be very close to what? Now the correlation for this new graphic is going to be very close to what, Evan? For this new graphic, the correlation is going to be closer to what? It won't be exactly this, but it's going to be close to this. Remember the trick we do to tell what the correlation is? Close to 1, right? And if the correlation is closer to 1, which it depends on sample size too, but the closer the correlation is to 1, generally the wider the p-value. The closer the correlation is to 1, generally the wider the p-value. So the closer the correlation is to 1, like this graphic, generally the wider the p-value. Well, it is stronger correlation. P-values would be more significant. The more significant a p-value is, so the p-value will be smaller. And smaller means more significant. Statistically significant is a p-value less than 0.05. So the stronger the correlation, the more statistically significant. And we can see this over here. We have a super strong correlation. And here's the value of correlation. You see how it's almost 1. And then this p-value right here is something like this. That's, whoops, I put a y right there at the start. The p-value up there is really, really tiny. That's a very, very tiny p-value. Does that make sense? So the stronger the correlation, the more statistically significant it is. The stronger the correlation, the more statistically significant it is. What does it mean to be statistically significant? It means that what we saw was what? It means that what we saw was unlikely by random chance. It means it's very improbable. Statistical significance goes with p-value. Oh, I didn't. Oh, sorry, Evan. Sometimes I get interrupted. Sorry about that. Statistical significance goes with the p-value. It means what we saw was unlikely by random chance. It means the p-value is below 0.05, and the p-value is the probability of what we saw being by random chance. So if it's statistically significant, that means the result was very unlikely by random chance. So we think it's significant statistically. Does that make sense to say statistically significant? Like, this is significant statistically. It's unlikely by random chance. So the p-value tells us if it is statistically significant. Which result, the one on the left or the right, is statistically significant? Which result, the one on the left or the right, is statistically significant? Which one over here is the left or the right result is statistically significant? The right, exactly, because this is a low p-value. And look how there looks to be correlation. This one is not statistically significant, and there is no correlation. So the p-value tells you statistical significance, and when the p-value is below 0.05, it is statistically significant. So that's how we can tell statistical significance right there. Excellent work. So p-value for correlation, which is statistically significant, implies that it is due to random chance. Statistical significance means the p-value is what? Statistical significance means what? Again, just repeat for practice. This is used in all my classes all the time, like 320, 474. Statistically significant means that the p-value is what? Very important. Like super important. Just have this memorized. Statistically significant means the p-value is what? Statistical significance means the p-value is what? What does it mean to say statistically significant? Small, yes, small. That is true. Below 0.05. So so go with this. A p-value for which is statistically significant. We don't even have to have for correlation. We can just say a p-value which is statistically significant implies that the correlation is due to random chance. Remember, p-values are probabilities. And so this is the probability it's due to random chance. So there's a low probability. So would that imply it's due to random chance, or it's unlikely due to random chance when it's statistically false? Because it's going to imply it's unlikely due to random chance. When it's statistically significant, we think it's not likely due to random chance. And so look at the two graphics right here, where we have one that is very statistically significant on the right, which is unlikely due to random chance, small p-value, and this one is likely due to random chance, high p-value. So the one that is statistically significant over here is unlikely due to random chance. It's just a true false, but it's a huge concept to know. Good work. What is the strongest negative correlation? So we're looking for the value closest to what? What is the strongest negative? We'll do this one more time, then we'll hop over to my Pearson next. What is the strongest negative correlation? What is the strongest negative? So you'll probably find it, and then just remember how to find it. The how to find it is the important part. What is the strongest negative correlation? Is it -3? Great job, Roshni. It probably is. Let me double check. I love doing this with code instead of reading through it. It's so much easier to do it with code. It's going to be the one closest to -1, so whatever that is. And once again, I just want to point out that in the upper level classes, we have so much easier of a way of doing this. I can even make it so I don't have to see all the output. I can just say outputs for rows 1 through 3, because I think the third one had it, and there's the strongest negative. Or I could just do which correlations are below 0. I can write code that just finds me the answer for which is the strongest negative, and I don't have to look through a big correlation matrix. Much either ways. Correlation matrices are not uncommon, though, so it's definitely a good thing to know. It's just if we're going to do it with code, there's a lot easier ways to do things. Which of the following is a bivariate display of quantitative data? Great job, Taylor. And so which is the correlation, which shows bivariate quantitative data? The answer's on the screen. Just make sure to write these down and practice these. This is where we say QQ straight enough, no outliers. Which of these is the display of bivariate quantitative? What is a display of bivariate quantitative? And see if you can go through and name which each one does. Histograms are univariate quantitative. Bar charts and pie charts display univariate categorical. Mosaic plots are bivariate categorical. So a mosaic plot, we did one last night over here. Here it is over here. A mosaic plot is going to be 2 categorical variables like did you watch the Kahoot? Did you make an A? So, but still we throw out lots of points. Victoria, we're going to throw 8,000 points. Mosaic plots show you the conditional distributions within a variable, and then you have the marginal displays on the side. So mosaic plots are bivariate categorical, and scatter plots are bivariate quantitative. Outliers can make a weak correlation strong. This is just like, oh, no worries, Victoria. And just getting everyone some points. We'll love it. Outliers can make a weak correlation strong. If you have a weak correlation down here, which looks like a 0, notice how the correlation up here of R is close to 0. And they put 1 point over there. Boom. But I haven't watched Kahoot yet, but we'll be getting that. Wait, I'm so confused. I got to send those out. People emailed me and I haven't emailed them back yet. Thank you, everyone. I think I got all the emails. I'll be emailing those out just after class today. Thank you so much. I went to bed way early last night. I went to bed at like 10 and I slept for like a long time. Outliers can make a strong correlation weak. Here's a strong correlation right there. And then look at that. Wow, we almost got it perfectly. You just mean so we have a strong correlation becoming weak. So what can outliers do when it comes to correlation? What can outliers do? Outliers can make a weak correlation strong. They can do anything. Anything is possible when it comes to correlation and outliers. Anything. So make sure to know that. We should have a 10 out of 10. We're going to do this one more time right here. We'll probably do it quickly because we did a lot of the review. So remember, it's not about just solving these questions. It's about being able to solve them, like being able to understand the concepts. Like you can memorize these answers. No worries. A p-value for correlation, which is statistically significant, would imply what? Finish this. Don't finish it the way it is. A p-value that is statistically significant. Chapter 6, we're going to do that. A p-value, no worries, Blake. Good work there. It was a tough competitive Kahoot. The lightning round changed around a lot of people. A p-value that is statistically significant would imply what we saw was what due to random chance. A p-value that is statistically significant would imply what we saw was what due to random chance. Well, if it's statistically significant, that means that the p-value is below 0.05. So it would mean it's what due to random chance. If it's statistically significant, that means it's what due to random chance. This is not statistically significant. Yes, unlikely. Because statistically significant means the probability is below 0.05, and that is the probability of our results or results more extreme by random chance given that null is true. So it's basically the probability of our results by random chance given that null is true. Like the probability of our results or results more extreme happening by random chance variation given that the null is true. But it's a probability of what we saw given the null is true. So think about this. This is likely to see given there's no correlation. This is unlikely to see given there's no correlation. Does that make sense? Like what I see right here, like this pattern I see is unlikely to see given there's no correlation. Thus, I have evidence for my alternative that their correlation is not equal to 0. This result right here is likely to see, that's the p-value, the probability. This correlation that I see, which I didn't give a value, it's just a correlation, is likely to see, because the probability is high, given there's no correlation. If there's no correlation, this is likely to see. If there's no correlation, this is unlikely to see. So it wouldn't, we would say it's unlikely by random chance. It's unlikely by random chance. So the whole phrase right here should be, I'm going to read it the proper way. Here's the proper way. A p-value for correlation which is statistically significant implies the correlation is unlikely due to random chance. Does that make sense? It would imply it's unlikely due to random chance. So it says implies the correlation is due to random chance. No, it would imply it's unlikely due to random chance. So this right here, because statistically significant means the probability is low that what we saw was due to random chance. This is false. But I want people to understand a little bit. So review that. I know it's just a true false once again, but review the concept because it's a big concept for the remainder of the semester talking about p-values. If the correlation coefficient of two variables is close to 0, this implies there's no relationship between the two variables. Let's do a poll right here, true or false. So answer the true or false poll. Go ahead and answer away, true or false, in the chat. What do you think? If the correlation of two variables is close to 0, this implies there's no relationship. What do you think? Great job. And why? Uh-oh. We're almost going towards 50-50. So a correlation close to 0. What is the true statement? Well, kind of. A correlation only implies there is no... A correlation close to 0 only implies there is no linear relationship. No linear relationship. So correlation close to 0. Great job, Justin, right there. Excellent work, everybody. We got to throw out some more points. And Justin, good review. A correlation close to 0 only implies there is no linear relationship. Correlation is only meant to measure linear relationships. So this right here, which of these graphics has a stronger relationship? Which of these graphics has a stronger relationship, A or B? I ask my students, like in the upper level classes, stuff like this all the time. They're like, they sometimes get it wrong. I'm sorry, upper classes. I'm like, no, we have to remember. Great job, Victoria, right there. You are right. Yep, exactly. A has a stronger relationship because the strength of a relationship is the vertical scatter, and there is no vertical scatter. This is a perfect parabola where this one is actually weaker. It's a little bit weaker, but it's more linear. So this one is going to have a correlation down here on the bottom. This one would have a correlation something like 0.80 because it's positive linear correlation. But this one up here up top is going to have a correlation close to 0 because correlation only measures linear relationships. So even though the top graphic A is stronger, it has a correlation close to 0. So the question reads, and let's make sure we see it again right here. If the correlation of two variables is close to 0, this implies there's no relationship. That's false because it just implies no linear. Correct. Yeah, exactly, Evan. The tighter the points are around the form. So Evan said it perfectly. This is a parabolic form up top. And so the points are very tightly around a parabola. Like if you draw the proper form to this, like I'm adding more points just to kind of accentuate it. If you draw the proper form, which would be a parabola, that's really strong. So to make it a weaker parabolic, you'd scatter the points more around the parabola. Now these might be similar in strength. I'm trying to draw where they have about the same strength because now there's more of a scatter around the parabola. We'll take away. Does that make sense, Evan? Now they are similar in strength-ish. About maybe similar because there's a similar scatter around the proper form. So now they have about a similar strength. Like that's similar parabolic strength to similar linear strength. But the linear relationship of the top one is 0. So correlation, if it's 0, only tells you linear strength, where a parabolic strength wouldn't be measured. But that is some sort of parabolic form with similar strength. So good answers there, Evan, and great review. To create a scatter plot, both variables must be what? Identify. No. I feel bad when no. To create a scatter plot, both variables must be what? QQ straight enough, no outliers, the conditions for correlation, quantitative. The correlation coefficient is not affected by outliers. The correlation coefficient is not affected by outliers. Here's a correlation that's strong. It's 1. Here's an outlier. Now it's 0. Wait. It's not affected? Correlation is not affected by outliers. Here's a correlation that is weak. So look at the correlation up here. It's weak. And then we throw in 1 outliers. And then 1 outlier right there. Wait. Wait. Oh, no, it's false. Wait, true. Correlation is very affected by outliers. That's why we say QQ straight enough, no outliers. So it's false. It is affected. No, correlation is not affected. Careful. Double check it. Correlation is not affected by outliers. So it depends on the way I say it, right? Correlation is affected by outliers. True. Correlation is not affected by outliers. False. Correlation. So remember the true statement. Correlation is very impacted by outliers. So outliers can make a weak correlation strong. Oh, sorry, Blake. It might be my brain. Yep. It does mean that, Victoria. You're answering the next one is true? Yep, this is true. So does that mean a strong relationship can have a correlation to 0? Correct. Because the relationship would just be what? So to answer Victoria's question, try to answer Victoria's question right here. So does that mean a strong relationship can have a correlation equal to 0? The answer is yes. The correlation would just be this. A strong relationship can have a correlation equal to 0. Yes, because the correlation would be this. A strong relationship can have a correlation equal to 0. Yes, because... Well, not outliers. Not so much outliers. I mean, that kind of applies, but a strong relationship, exactly, nonlinear. It would just be nonlinear because correlation only measures linear strength. So there can be a strong, hopefully I didn't say correlation. Correlation only measures linear strength. There can be a strong relationship. As Victoria said right there, a strong relationship right here at top can have a correlation equal to 0 because correlation only measures linear strength. So this one's strong, but it's not linear. Does that make sense? Strength. And so repeat it again. Why is this strong right here? Why is this relationship in these points strong right here? Why is this a very strong relationship? Why would this be very strong? Why is this very strong? And the points are clustered around the form. So strength is the vertical scatter. And if you notice, we've got some sort of upper or higher polynomial quadratic type thing. And so there is some sort of bendy form that would go around this. Great job, Wes, right there. So that's very, very strong. But it's also very, very nonlinear, which means the correlation is going to be close to 0 because a flat line goes through it. Correlation only measures linear strength. So things can have correlation of 0, and then you're like, oh, they're not correlated. Well, but they're still related. They still have an association, but it's nonlinear. So if you have something that has a linear correlation, then it's going to have an association and it's going to have correlation. Very important right there. I think that's what a lot of people just say, oh, two things are correlated. Well, correlation is only one type of relationship because you wouldn't say watching the review is correlated with your grade because both of these variables are what? Because this is a mosaic plot now. Last review question right here. Then we're going to do the homework, I think. So watching the review, you wouldn't say is correlated. You would say associated. How are several scouts? Is that homework, Evan? Where's that from? Off the quiz? Yep, we can try to find it right here. We do the quiz. Let's do this. Let's take a vote. The quiz is the hardest one. Oh, we should do the quiz, right? Do that one. Okay, it's got 2 votes. Let's do that next. So you wouldn't say these two things are correlated. Why? Why would you not say watching the review and the grade you get is correlated? It's like my biggest pet peeve. Why would you? So quiz, we'll do some quiz right here coming up right next. Why would you say they're not correlated? Oh, no worries. Let's do the quiz. And why would you say these aren't correlated right here? Because correlation only applies when both variables are what? Correlation only applies when both variables are what? Correlation only applies when both variables are quantitative. Great job, Justin, right there. Yep. It only applies when quantitative. So you wouldn't say your grade is correlated with watching. You would say associated. Does that make sense? You could say watching the review and your grade are associated because you're more likely, like this is categories right here. You're more likely to make an A if you watched, but you can't say correlated because correlation only implies quantitative variables. Just a big thing right there. If you're talking correlation, the first condition is QQ, straight enough, no outliers. Those are all three. Let's do the quiz. Here we go. Oh, we got some tough quiz questions. Thank you so much, everyone, for being here. Let's go do the quiz. Okay, so what was the question people want? We got 23 minutes. Let's see. I'm so confused. Here we go. Assignment manager. Here are several scatter plots. The calculated coefficients are, which is the output. Okay. Here are several scatter plots. Woo! There's a lot of questions on this. Here are several scatter plots. Oh my gosh. Oh. There's so many questions. Like sort of some easy ones and some more difficult ones. Here are several scatter plots. Okay, so here we are at the 38-33 mark. Stat 201 and chapter 6 quiz. Here are several scatter plots. Okay, let's go check this out. Okay. Oh, great job. You even said, thank you so much right there. There it is right there. So, yeah, that helps kind of. I think they're in order. So here are several scatter plots. Okay. Which of these scatter plots, A, B, C, or D, shows a non-existent weak correlation? A, B, C, or D, which of these shows a non-existent weak correlation? Which of these A, B, C, or D shows a non-existent weak correlation? Oh, it did. Good questions are Blake and Evan help each other out. D. So D is going to be which of these correlations? D is which of these correlations? Which one is D? Because D is the weakest. It looks more like a 0. So it looks more like a 0. Which ones would those be? D is the weakest. Great job right there. So D is going to be negative 0.021. And then which of these is the strongest negative? A, B, or C? Which of these is the strongest negative? A, B, or C? Which of these is the strongest negative? It'd be B, right? So B is the strongest negative, and that's negative 0.923. Which of these is the strongest positive? A or C? Because we're down to these two. A or C? Which of these is the better linear relationship? A is the better linear relationship. It has a stronger linear association. This one's a little bit non-linear. So A is the stronger linear. So we take the strongest linear right here, 0.951. And last but not least, we have the last one, which does have some linear relationship, but does also have non-linearity. And we check our answer. We should get it right as long as we do decimals. We got it. Does that make more sense right there? Just going through process of elimination. Some of the easier ones, like the no association right here, having a correlation close to 0. This one is negative, so it's easy to see strong negative, strong positive, strongest linear. Maybe a little toss-up between these two, but they're similar in scatter, but this one's more linear up top. Can we just work through a few of the long ones like roller coaster? Yeah, we can do roller coaster next. Where's the roller coaster one, or how does it start? Can you explain why correlation between SHU and GPA of freshmen actually matters? I don't see the point of how. Which one is the question, Evan? Let me know what the question is. I don't know that one fully off the top of my head. You want to do the hurricane one? So the hurricanes. Is it the hurricanes one? Let me find the hurricanes one. Is it just somebody start the question, then we'll find it. Fastest horses. Tell me the start of the shoe size one. We'll find the hurricane one. What is the hurricane one? There's so many questions. I wish I could just control F through all the questions. On the review guide, what does simulations and associated terminology? So simulations can allow us to model reality, like if I want to do something like flipping a coin. So simulations are a good way we can use randomness just to simulate things at any time. So if I go right here and say sample from heads or tails, sample one thing right here. I can sample. Oh, I'm still doing the core demo. I can exit out of core demo. Good. I can sample heads or tails, and I can model reality with a simulation. So the idea of simulations are just that we can use randomness right here to simulate reality. And I might mention that again. I think that's about the only thing. I'm going to see what questions are on the exam on that. But it's such a small thing and not that big of a, like, it's not that big of a topic. And so I'm going to make sure there's no big questions on it. It's just that pretty much randomness can be used to simulate reality. So we use statistics. Statistics uses randomness to simulate reality. It's like I think it's like 2 or 3 slides. It's very, very small. But yeah, it's at the very end of chapter 1. And it's really just like statisticians use randomness to simulate reality. So this is me using randomness right here to simulate reality. I'm going to double check the questions, but I don't think there's anything. I think that's basically it. Like I'm actually kind of saying the answer to the questions, that statisticians can use randomness to simulate reality. Like we use random number generators, like I was just doing right there. And we just do that. What question is there? We're going to do the hurricane one? Should we do the hurricane one, or people are saying shoe size? Here we go. Here's the hurricane question. I like this question. Never mind which one. Let's hear it. Let's do the hurricane question. Okay, you ready? Time for the hurricane question. So with this, I know, right, Natalie, there's a ton. Like I'm trying to find. There's 29 questions. So the sign. Okay, so they've got Hurricane Katrina right here. Had winds that went 120 miles per hour from its center. Katrina was a big storm, and that affected how we think about the prediction errors. Suppose we add 120 miles to each of the errors to get an idea how far from the predicted track we might still find damaging winds. So we're going to add a constant. So the best way to think about this question right here is to think about grades in a class. So if we have grades in a class and how long people studied, so we have X is how long you study. And study would be something like this. We're going to put them in order right here. And we've got a bunch of people's hours that they studied. People studied between 0 to 5 hours for the test. Then we have your grade on the test. And your grade on the test would be something like this right here. And we have something like 70, 72, 75, 76, 80, 85, 90. And we're just putting them in order, 90, 95. Now, if Brian goes in, which have the same length vectors, if Brian goes in and adds 5 points to everybody's grades, everybody increases. Does that make sense? Everybody's grade goes up. So if I go +5, and what would happen to the correlation between how long you studied and your grade? What would happen to the bivariate relationship? If I had +5 to everyone's grade, what would happen to the relationship between your study time and your grade? Nothing, correct right there, right, Blake? Nothing's going to happen because this person over here, I think I've done enough numbers, the relationship, the bivariate relationship would remain the same. Adding a constant or multiplying would not change the what of your grade. So what about your grade would not change? Like the person who has a 70 would still have the same what if we had a constant. Hint, the mean would increase by 5. So the person who had a 70, what would happen? And actually, I can show it theoretically, because if we have observation minus mean over standard deviation, well, if you go right here and you add +5 and you do the mean +5, Well, what you're doing right here is when you subtract the plus 5, that's just going to go away. So you would still have the same what. You'd still have the same what. Your what would still be the same right here. So those would be equal. You would still have the same z-score. So that's I didn't even think of this till now. So when I've been teaching the class for too long, I start to do mathematical proofs to say, if you add plus 5, the plus 5 would go away. Not sure which one, Victoria, do you want to do? Did Victoria have a question that you want to do that one? Tell me which one, Victoria. We'll do that one next, Victoria. So think about this. The z-score does not change. You still have the same z-score, and correlation is found via z-scores. So correlation is unitless like z-scores. So the sign of the correlation would not change, and the magnitude of the correlation would not change because the z-scores that correlation is based upon would not change. So this is the mathematical proof right here to say if you add plus 5, when you do observation, the observation would get 5 added to it. The mean would also have 5 added to it because we're adding 5 to everything. So the mean would be 5 higher. So when you subtract, let me ask, maybe I shouldn't do mathematical proofs. Does anyone on watching right now understand the mathematical proof that if you had your original data and then you added plus 5 over here, the plus 5 would just be subtracted off from it, and then you would just have right here the same observation minus mean, and you would get the same distance. So the plus 5 would go away, and then these two things are mathematically equal to each other. So adding 5 to it doesn't matter. For the ice cream, that's what we're going to do right there. For the ice cream and the AC, we'll do that one next. But I don't know if the mathematical proof helped anyone figure it out, but that is mathematically proven right there. And every once in a while, some proofs can help us out. Let's do the ice cream one. Ice cream and AC, people are saying. Do we have a number on that? So Stats Wheel 1, Chapter 6 quiz, ice cream and AC. Do we know which one that is? The ice cream and the AC. World Happiness Report. That's our second one done. We should get a lot more done. Probably have time. Wait, there we go. Ice cream and AC. I had the one on the homework. It's a homework one, is it? About the AC and ICC or other stuff. Okay. How does the question start out? How does the question? You say it's 14. What should be exactly 14? Oh, it's fastest horse race for us. Or you're saying it's 14 up there, I think. How does the question start? There's a question on the quiz that's like 5 parts asking about scatterplots. Can we do that one? Yeah, put the start of the question, and we'll do it here. Drop the start of the question, and we'll do it. A study compared the effectiveness of several antidepressants. Suppose you were to collect data for each pair of variable. Okay, let's do that one. That's one people have been asking about. Suppose, and then we'll do the other ones here. I think we have time for probably 2 or 3 more. Suppose you were to collect data. Okay, here we go. Oof, it's a long one. Oh my gosh. Oh my gosh. Okay. Suppose you were to collect data. Suppose you were to collect data. This is a new one. Okay, let's check it out. 50. If we don't get to questions, we will do it during afternoon office hours. Suppose you were to collect data. No, these are too. I don't like questions like these. We can learn. We're gonna learn some good stuff from these, but not a big fan of these. Let's check it out. Number 12. Let's do 12 here next. Thank you, Victoria, for seeing which one it is. We'll do 12 next. Let me put that down in the notes so I remember to do it next. And then I'll write down which one it is. Thank you, Victoria. Chapter 6 quiz. I'm going to put 12, and then I'll mark what it is after this. You got it. That one's coming up next. So suppose you were to collect data for each of the pairs of variables. You want to make a scatterplot. Which would be best suited as the explanatory and which would be the response? Not a bad question to ask. Why? What would you expect to see in the scatterplot? Discuss the likely direction, form, and strength. So it's just getting you to think through. So apples, weights in grams, weights in ounces. Which variable would be best as the explanatory variable and which would be the best as the response? Yeah, I think either one, it doesn't really matter. Either the weight in grams or the weight in ounces can be the explanatory variable. Then the other would be the response. And this is literally just a mathematical formula. So weights in ounces totally explains weights in grams. They're 100% correlated. So then the other would be the response variable because weights in ounces can be predicted. It'd be perfect. So it's not a bad question. It's just having you think through what you would have right here is that there'd be this perfect relationship, ounces and grams, and which one is which really doesn't matter, but they would perfectly explain each other. Not a bad question. What would you expect to see in the scatter plot? It would be positive, straight, linear, and strong. So, yeah, it's going to be perfect like there. So then we were able to think through that. Good answers right there. And great job, Justin. For each week, ice cream sales and air conditioning. Well, usually we're in analytics, so I probably want to look at the sales of ice cream. So they might say either ice cream sales would best be used as the explanatory variable is probably going to be AC, and ice cream sales would be the response to predict ice cream sales based on the air conditioning. So that makes more sense to me. It's also going to be probably so it's AC air conditioning sales. Yeah, they're probably positively correlated. That the higher the ice cream sales, there could be a non-linear relationship at the end. I don't think they're going for that. The answer for this one is A. Victoria, do you know the answer? That either one could be used? Because technically you can always flip-flop them. So you can always technically flip them. Okay, so they're both, that's what they're going to say down here. Oh, Victoria saving us. You had it on your homework. It is A. I like to do analytics. I like to do business analytics. See, that's where I'd get mad at my Pearson. We wouldn't use this on a test because I would think from an analytics standpoint, well, I guess because it's AC sales. So they're both sales. Thank you, people, helping me out right there. I prefer to predict ice cream, though. So it's either for most of them, yeah, because really you can always flip-flop X and Y, and the correlation between Y is the correlation between X is the same as X and Y. So it's going to be positively correlated right here. As one goes up, they're both going to go up. It's going to be weaker than the last one. You're saying that we won't use this on the test. Yay, you're welcome right there, Evan. Yeah. With this, we don't usually like things like this. College freshman, shoe size. This is the population of interest right here. The shoe size and grade point average. So that's going to look closer like what? The shoe size and GPA is going to look like what? Shoe size and GPA is probably going to look like what? Not like those. There we go. Shoe size and GPA is probably going to look like what? Which I guess this one doesn't really matter either. Like pretty random, right? Random. Mubot loves some randomness. Bunch of random dots. It's going to look random. And are they going to say it doesn't matter here either? Either grade point or shoe size can be the explanatory. The other would be the response because grade point can be predicted by shoe size and shoe size. Yeah, but neither can be really predicted. It's not possible. No, you can. Yeah. Yeah. The scatter plot would have no direction, no form, and a weak correlation right there. Hopefully we don't get one of these wrongs. Gasoline, number of miles you drive since fill up, gallons remaining in your tank. So you'd probably want to predict how much gas is in your tank, right? You're saying it's this right here, the weak. Are you saying this one right here, Victoria? Is this what confused you right here? Or are they saying we should predict grade point average? So you guys, everyone's saying it's grade point average, right? So they're saying they want to predict grade point average. I don't like this question. I'm glad we're doing it. So grade point average would be the best use as the explainer. You're saying its grade point is the explanatory? No way. Are you serious? It's B. Okay, that makes a little more sense. B being the explanatory, they're saying shoe size because you'd want to predict someone's grade point average. That makes more sense. Like if you're going to predict something, you'd probably want to predict grade point average. We probably don't want to predict shoe size. Like you can just measure someone's foot and know their shoe size, but if you predict someone's grade point average, you're kind of predicting the future or saying their success in school, which you kind of care more about. So that makes a little more sense, but still, this is such a nonsense relationship that I just don't think either is well suited for an X. Like I wouldn't use shoe size as an X variable. So want to know who wrote this question. I want to talk to them and say this is just ridiculous. So it's going to have a weak no correlation for certain though, like I would expect. Yeah, let's talk to him. Say, what are you doing right here? This one, I think you should be predicting. This is the only one I would think where you would be predicting the number of miles you drove since last fill up, gallons remaining in your tank. Which of these do you want to understand? Thank you so much right there, Natalie. Which of these, see, Justin, which of these do you want to understand? Gallons remaining in your tank or the miles since your last fill up? Which of these do you want to understand? Which of these do you want to understand? This is the one where I was like, they have to be going with this. Which of these do you want to understand? I'd want to understand the gallons remaining in your tank. So that makes gallons remaining in your tank the what variable, Evan. If you want to understand that, that makes it the what variable. If you want to understand that, that makes it the what variable. It makes it the variable of interest, and we call it the what variable. The response, the y variable. I call it the y variable, like why. Why do we have a certain amount of gallons in our tank? So the explanatory variable would be the number of miles driven would be the best explanatory, and gallons remaining is the response variable to predict the gas remaining based on the miles you've driven. So we want to predict the gas we have remaining. So what would you expect? So the more miles you drive, the what your gas. The more miles you drive, the what your gas. The more miles you drive, so it's the number of miles you've driven and the amount of gas. So negative, less, exactly. Does that make sense? We should get everything right. Hopefully we don't get one wrong. Woo! I got to throw 1,000 points for everyone helping me out right there. Yeah, I think the only things we got wrong right there, which is a bit ridiculous, are the ones like, oh, you want to predict GPA. Well, I guess. I mean, I don't, maybe people want it. Maybe we work for a shoe store. Maybe you work for a shoe store and we want to know your shoe size. So maybe my Pearson. Yeah, that the last part of that one was excellent. The other part's not so great. So this one right here, there's a few versions of it. Let's work it twice. I do love this question. There's questions I love. There's questions I hate. SAR questions. Which of these scatter plots? We added a lot of questions this semester, and a few of them need to be curated. I already curated a few from a few chapters. Okay. Yeah, exactly, Victoria, right? It doesn't make sense. This one is a great question. I've done this one a ton of times because when you look at it, and we might do a different version of it, the first thing you want to see over here is which of these, A, B, C, or D, or E, we're asking right here, these questions. Which of these have little or no association? Little or no association should look what? Just look at these right here and think which of these have little or no association. And little or no association should look what? And it is number 3, and it should look random, right? So be careful. We could have other versions of this question which show us nonlinear. I'm trying to see if I can get another version. There. Oh, 2 seconds. There we go. I turned off Alexa. So right here, you'll notice which of these has no association. It would only be number 1. Oh, I totally changed the question. Number 3 right here has a non-linear association. Does that make sense? Number 3 has a non-linear association. So which of these show no association? It's still only number 1 because number 3 has a non-linear association. So this is associated just non-linearly. So with our version that we currently have, which of these show no association? It would be number 3. Number 3 is no association. Which of these have a negative association? So we just have to look which ones go down. Which of these has a negative association? 1, 2, 3, or 4. Which of these have a negative association? 1, 2, 3, or 4. 1, 2, 3, or 4. Definitely 1. So only 1 right here has a negative association. And which of these show a linear association? 1, 2, 3, or 4. Which of these show a linear? 1, 2, 3, or 4. So when you ask for linear associations, you're just asking, does a line go through the data? Great job, 1, 2, 4. Because we're just asking, does a line go through the data? And does the line go through the data? Well, rather, a line can always go through data, but 1, 2, and 4 have linear associations. 3 does not. A weak or moderately strong. So now they're asking about strength, which is the tightness of the scatter. So which of these is a weak or moderately strong? So this is where we got to be careful. A weak or moderately strong. Now I'm worried because there's two possible answers on here. And because I think they made a small change. Well, you see, here's the thing. They're saying no, little or no association. So we've already defined 3 as little or no. So what do you think the answer is? We've already defined 3. Exactly. So since we've already defined 3 as, does this make sense, Victoria, right here? And good to see you here, Paul. Since we've already defined 3 as little or no association, then I'm going to say that this has no association and that 2 is the only one. This is the only question I'm worried on right now. 2 is going to be a moderately strong, and I wish they wouldn't group together weak or moderately strong, but this one right here is moderately strong, I would say. So that qualifies. I'm a little worried about number 3. I'm saying it's no association, so I'm not going to put it down here as weak. Which of these show a very strong? That is definitely 1 and 2. Or 1 and 4, sorry. 1 and not 1 and 2. 1 and 4 right there. 1 and 4 right there. Good thing the answer wasn't there because my brain just saw it too quick. We should be right. I'm a little worried about the one right there. Woo! We got it right. So I think some of the ones people usually miss are when you get the nonlinear ones. So we'll show one of the ones that has the nonlinear relationship. So that's super strong right there. 3 right there. When it says very strong, 3 is going to be in the very strong. See how 3 right there is very strong due to the scatter. This one right here is a moderate. So that's a moderate. I'm trying to find another where it shows the nonlinear. This is moderate strong. This is maybe weaker. So 1 and 4 would be the moderate right there, the moderate right there. So those are moderate right there, 1 and 4. I'm trying to find that nonlinear just to show it and show you how the answer would be. This right here is a nonlinear, but it's also moderately strong. So that's going to be moderately strong, moderately strong. So the moderately strong are 1 and 2. There it is right there. And then the very strong is 4, and the no association is 3. This is, I really like this question if you can't tell. Oh, thank you so much. Thank you, Evan, right there. Dropping that, helping people out. We love that. Evan, let's add you 2,000 points. Thank you so much as I'm answering this question. Evan, helping people out in the chat. Thank you so much. Can you explain moderately strong versus weak? So when you talk about moderately strong, it's the tightness of the points. So weak is going to be something where the points are more scattered. So weak relationships look like something like this right here. This is very weak. It does go up a little bit. This is maybe correlation equal to 0.2. You could also have a weak nonlinear. So this is maybe correlation equal to 0, but there's a nonlinear form to it. Both of these have about the same vertical scatter, where if we draw the line through it, which is the form, they're both about the same vertical scatter. Where stronger, like moderately strong, here's a non-linear moderately strong. And if you look at the parabolic form, the points are tighter. And we draw the same sort of scatter around it here. And so the form being non-linear or the form being linear. So now when we look at the scatter of it, the points are more tightly clustered. So this is going to have correlation equal to 0 again because it's non-linear, but it is stronger. This one might have a correlation equal to something like 0.8. Does that help out right there? Does that make sense? That the more tightly clustered it is around the form, the stronger it is. So the ones on the left would be weak relationships. These are weak, and these are strong, moderately strong, strong, stronger. So those are all right there. Awesome. Getting an energy drink. Do I go to the pod market now? Run by the pod, get an energy drink. So the strength of the relationship is the tightness around the form. That's got it. I don't know. It didn't send. Redo the quiz. Redo the quiz. Let's head over to the main screen. I think I'm going to grab some breakfast real quick. Busy morning. Well, job stuff. So many things. Let's see. Okay, gonna send out. Logged out of Canvas. Oh my gosh, Canvas, no. Stop logging me out. Oh, I'm not logged out. Ugh. Canvas, what are you doing? Reviewing for test 2. Oh, people are already in the chat. What does recognizing what is not a variable at all mean? I don't know. That's a good question. I don't know if we have ever made a test question for that. I don't know. That's such a weird... Is that on the review sheet? I should ask Terry that. I don't know. Makes me wonder one of the questions I looked at, because I'm like, no, those are pictures and stuff, our data. I'll look at that. Let me look at the questions. It's on the review sheet. Awesome. Coding in R. Bring it up. I looked it up and started bringing up coding in R. Well, I'll take a look at that, Blake, right here. We'll check this out. Class in 12 minutes. I'm going to grab some breakfast. Until then, bye for now, everyone. Be back soon. Bye. Be back here soon. Go look at that question, Blake. I don't know if we have any on the test about that.